Good afternoon, everyone. My name is Daniela. I'm a roboticist and the director of MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL as we know it, and also Deputy Dean of Research in the Schwarzman College of Computing. Welcome to today's installment of Hot Topics in Computing. Now, our guest today needs no introduction, but I'd like to give him a short one anyway. Neil deGrasse Tyson is an astrophysicist and arguably the world's most well-known science communicator. For nearly 25 years, he directed the Hayden Planetarium at the American Museum of Natural History, while also writing dozens of books and hosting beloved TV shows and podcasts such as Cosmos, Star Talk, and Nova. Neil received his bachelor's degree in physics from Harvard and his PhD in astronomy from Columbia University. And in addition to his degrees and his extraordinary presence in the media, Neil received more than a dozen honorary doctorates as well as many awards. And what I would like to highlight today is the NASA Distinguished Public Service Medal, which is the highest award given by NASA to non-government citizen. He's even got an asteroid named after him. Neil, I'm so delighted that you made time in your busy schedule to join us today to continue the conversation we started in December, to talk not just about the stars, but also how astrophysics relates to the computer science world. So Neil, welcome back virtually. Welcome to MIT.
Yeah, well, thank you. Thanks for having me back. I love your audience. That's always inquisitive and energetic and with a verve for learning and asking questions. And so I'm all in. I'm all in for all of that. So
I hope you're
bring
ready.
It on. That's right.
I hope you're ready, Neil, because back in December, I had about 200 questions from our amazing students left after our conversation. And that number has doubled. So let's get started.
Okay, let's do it. That's just a question every 20 seconds. That's not a problem. We can. Okay. No.
Let me start with some questions around the rise of data and AI. Do you see potential in AI to solve general questions about the universe? Or will AI be used to crunch numbers and equations?
Yeah, so I don't see AI getting ahead of us in our cosmic inquiries. Now, maybe that's just because I don't want it to. And so I accept that bias that I may have. I think I recognize that bias. But so much of the questions we ask about the universe come about by looking up and saying to ourselves, that's odd. That doesn't match what it should. That's unusual. Isaac Asimov made the great author and science writer over many decades. He made the perceptive point that true scientific discovery, contrary to what we think of with, not Aristotle, Archimedes, contrary to what the legend would have you believe, true scientific discovery doesn't come from somebody saying, Eureka! It comes from somebody saying, that looks odd, right? What's going on there? And so I guess AI, if it's a complete mapping of all that it is to be human, that I suppose in principle, you could inculcate it with a sense of curiosity so that it will explore things it doesn't know and then bring to bear on it what it does know to try to solve it. I don't see why that couldn't be the case. But I don't know that we have good examples of AI. Yes, we have AIs finding solutions to problems that had eluded people. I knew that took place in chess and in Go, even in something as simple as juggling. There were solutions to these tasks that we've had for so long that the computer just found another solution to it. But would the computer be able to invent another game, for example? Right? I'm still wondering whether AI can get the full sort of abject creativity that we know humans are capable of. Is AI going to paint this behind me? Is it going to come? Will it even think to paint something like that? So I don't know. So and I think cosmic exploration is so, every year it's like, who ordered that? What? Oh, two black holes colliding. What did that? Oh, let's try to measure that. Okay. Oh, the universe is expanding. Oh, the universe is accelerating. Oh, the universe had a beginning. Oh, there might be a multiverse. I don't see AI anywhere on that landscape. So I know it's your whole bread and butter, but I'm thinking it'll be a long while, if ever, before AI is sitting right next to me, scratching our head, whatever the AI scratches, to try to figure out a new question and a new problem that sits in front of us. So for me, it's the data crunching that happens once we've already established the problem, and now we want to calculate upon it.
So in an ideal world, if you could have anything out of an AI or machine learning system, what would you like as an astrophysicist?
Oh, I was thinking, what would I want as a person? Let me answer that first. I'm ready for self-driving cars. I'm ready for that.
Working on it, Neil. I'm working on it.
Are you okay? Well, hurry up, okay? All right. I got two kids who don't want to drive. One is like 20 and the other is 24. And I'm from the city, so they don't want to drive. And they're like waiting for you to send the self-driving car. Okay. So
they're coming slowly.
what I like especially about the self-driving car is that it will know about all other self-driving cars in its vicinity. So if it had to change lanes, it just tells them, I'm changing lanes, and then they part the seas, the car changes lanes, and so the sources of so many accidents would just evaporate overnight, and you'd have a safety factor that is, we're still losing 100 people a day to car accidents on the on the freeways and highways and pedestrians in the United States. So that would take that near zero, if not identically zero. In astrophysics, let me think. I see AI. I'm forgive me, but I keep thinking of AI as a tool to help me do what I'm doing, rather than what I think a full-up AI should be capable of doing, which is completely replacing me. All right, I send the AI to my office, okay, and let it handle all the phone calls and write the book. And because if it's true AI, then it should be just like me or better, especially better. All right, and so I don't know where to put the dart into the AI table to say this is where I want it versus this is where it will ever reach. So I don't. That's probably a very unsatisfying answer. But I still think of AI as just really good computing, helping me solve the problems that I posed and the questions that I am investigating.
Well, Neil, that's a view that's consistent with many of our views. We're just trying to make the tool more capable. And someday, I hope we have a chance so I could tell you about how long till those self-driving cars do what you just said. But since we're talking about AI and tools, what computing technology from today would you have the most trouble living without?
Oh, definitely the smartphone. I think the smartphone is the greatest thing ever conceived and invented in the history of civilization. I don't think anything comes close to it. And it happened in our lifetime. And by the way, at any generation would say that about whatever they might have invented, right? Let's go back 140 years or 30 years. The telegraph. Oh my gosh, that's going to change the world. Oh, we could, and they lay down a cable across the Atlantic. You talk to Europe when it used to take you, however long to sail. And so, sure, when you're on an exponential growth curve, if you are anywhere on that curve, it will feel like all the greatest discoveries happened just in the few recent years. But so it's not that you're living today in a golden era. The entire era is a golden era because everything is happening exponentially. And so where do I come off then saying the smartphone is the greatest thing ever? Just simply because of what technologies it has merged. I mean, it's extraordinary. It takes better photos than most people ever took ever in the history of the world. More photos are being taken. And this started out as a telephone, a freaking phone, okay? And I remember the early camera capacities. It was a fuzzy photo and it wasn't good. and it was just like for an emergency. Now, that's my camera of choice on my telephone. Oh wait, it's not a telephone. It's not only a telephone. It's access to the whole world's information. Plus, where do I make the turn to get to grandma's house and avoid the traffic? Let me check the phone. And it's getting information from satellites. Satellites that has precision timing. And the timing is so precise, it has to be corrected for Einstein's general theory of relativity because of the time dilation for it being so high up. Actually, it's the opposite of time dilation. The satellites are so far away from Earth's center and Earth as a source of gravity that time ticks differently for it. And if it's giving you the time that you think you need, it has to correct for that before it hands it down. So this is a technology that is using like relativity, space physics, internet, photography, and I'm thinking, what's left to do? So if I were to go back and bring one thing to show Isaac Newton, it would be the smartphone.
Well, I'm excited you really like the technology that was produced by our field broadly. Do you have any fears about it? And in particular, maybe connecting it to AI. What is your biggest fear with respect to AI? We know that last year you agreed with a fellow podcast guest who said that the world's largest existential crisis is within AI. What are you afraid of? And has your opinion changed since then?
I don't think if I agreed, it might have only just been a mild agreement. You know, we've all seen the movies with AI gone bad, and often, I don't know if I said this when I was last your guest, but the science fiction writer Ray Bradbury is famously, in response to a question posed to him, the question was, Mr. Bradbury, why do you write these future stories of science gone bad, an apocalyptic Earth? Is this the future you think we're going to have? And he said, no, I write these stories so that you know what future to avoid. So I don't mind the apocalyptic movies. They sell tickets, and they're always kind of interesting. And maybe that'll help reset our cautionary urges to say, no, I don't want that to happen. No, that's pretty bad. Oh, okay. So, and that's true, of course, for any technology. I think there are other more tangible existential threats than AI, and that's why I part ways with even AI experts who say this and feel this. For me, the question is not, will AI take over the world? For me, that's not the right question. The right question is, when you have AI ability, what are you most likely going to do with it? And I don't see anybody. Maybe in your basement you're doing this, and you're not going to tell anybody. But personally, I don't. And I've been on compute. Okay, I'm not like total computer engineer, but I've had my days on computer. I probably coded 50,000 lines of computer code in my life. Most of that in graduate school, and shortly thereafter that, and in college, about 50,000 lines. That's respectable, but it's not as much as like real professionals at it. But I have enough of a baptism to I think that I have my thoughts have some foundation. That's really what I'm trying to say here. So when I think of computers and what role they play, my first thought is not, let's have the computer do everything. That's just not my thought. My thought is, let me get a computer that makes a perfect cup of coffee. Do I need that computer to guide my self-driving car? No. Do I need my self-driving car to run my laptop? No. Do I need... So if you're going to now say, AI will be all of this all wrapped up into one humanoid bot, who's going to do that? I can't picture that as anybody's priority, because anything you roll up into one thing, I don't think is going to be good as the very specifically tasked computing tool that is applied to specific things in your life, making it better and perhaps even perfecting it. So I know general AI is supposed to be able to do all of the above. Okay, is it going to walk my dog for me? Is it going to go to the beach for me? People talk about, oh, we're going to upload our brains into computers and then we're in the computer. I'm going to take a stroll on the beach and meet 3 people. Did the computer do that? No. Okay, so it's not me anymore. All right? I continue living a life of a flesh and blood human being because I have 2 legs and I can walk down the frickin' beach. All right? Whereas the computer on the shelf, it can think about it, I suppose. It can imagine meeting new people, I suppose. And maybe that's good enough, and maybe the difference doesn't matter. Like in the movie The Matrix, if it's just all in the head, who even knows and who even cares? Maybe we're all in the Matrix right now. But I just don't see the all-purpose computer taking over everything. I just don't see that.
I agree. Let me move on to the next question.
Can I add one thing? Sorry. And again, I don't remember if I said this last time. I'm old enough to remember the Jetsons. This is a Hanna-Barbera cartoon that like coexisted in time with the Flintstones. It's interesting to have the Stone Age and the future all as like primetime cartoons, half-hour cartoons that were part of the canon of what I grew up with. And in there, of course, he's in a flying car, of course, it's the future. And he's living up in the clouds, of course. All right, so what do you have? Well, they have a robot maid. And it looks like it's wearing like a maid thing, okay? And so the maid is like pushing the buttons to clean the laundry and to do the things. And I'm thinking, no, you don't need the maid to push the button. Let the laundry machine be the computer. You don't need a robot to get in your car to drive your car. Your car is the robot. So all of these movies that show humanoid robots, who's going to do that? No. I've seen some attempts at it. I don't see any people lined up to get a human robot walking around their house. And if the demand isn't there, the supply is not going to be there. I don't see it. Sorry.
In fact, it's interesting to think about the robotic technologies over the past 50 years. Many robots were actually inspired by the human form, with arms and humanoid shapes, but we can roboticize everything in the built environment. We can create so many more shapes, and that's where the robotics future is.
Very important. And let me echo that, because the idea that you would create a robot that's humanoid comes with the implication that the human form is some ideal thing. No. I mean, wouldn't it be great if you had 8 arms like an octopus? All right, that would be like you could be really effective. I mean, just be a little more creative about that. Right, to create another human, I don't need that. I got enough humans. I don't need you to make a robot human. No. Yeah, so you tune the robot for the task physically, kinetically, so that task is perfected by the morphological form of that robot. And you know something? When you've done that, that robot is not the robot making your morning coffee or your laundry. And it's not the one driving your car.
So we have a number of students working on exactly those problems. But let me move on and ask you about more astrophysics. Harvard's Avi Loeb argues that Oumuamua was an interstellar alien probe. What do you think?
He was able to get very few people to agree with that conclusion among his colleagues. So we can talk about this outlying idea, and part of what made it get so much attention is his academic affiliation with Harvard. You barely ever saw his name without Harvard, chair of the Harvard department. So he would ride in that sort of Harvard affiliation in the recognition he was getting for those ideas. Very few people aligned with that. But apart from that, and by the way, in science, if you have you can have crazy ideas that turn out to be true. But generally, the effort to establish that truth is you go through peer review and you say, no, you forgot this, or no, you forgot to cross the T, dot the I, carry the two. And if you can't get colleagues to embrace what you just came up with, then maybe you should rethink what you're doing. Okay, that's the whole point of peer review. But so anyhow, his paper, by the way, that suggested Oumuamua being just to make sure we're all on the same page, we the astrophysics community discovered our very first. We've been looking for these for decades. Our very first interstellar visitor coming through the solar system. And you can determine that instantaneously by establishing its orbital parameters. Not instantaneously, you get a few positions of its orbit, and is it on a hyperbolic orbit, or is it on an elliptical orbit? If it's hyperbolic, it does not belong to this solar system. This, we knew from Jump Street, it did not belong in the solar system. It got a lot of attention because of this. Then we noticed, the people the asteroid solar system folk, noticed that it had what's called an anomalous acceleration. You add up the gravity of all the planets and the sun and everything else you know about, and it's moving a little extra than what the gravity that should be influencing it could account for. And so, by the way, that's not so weird in the solar system. Comets exhibit this all the time. Why? As they near the sun, heat from the sun sublimates the ices, and you can get ice jets, gaseous jets, creating thrust on what's otherwise a nicely Newtonian path, thereby disrupting what you might otherwise think is the perfect laws of gravity. All right. The problem with Oumuamua is nobody saw any jets coming out of it. There was none of this telltale cometary fuzz. And so that meant it was a conundrum. So people for a while said, we don't know what's causing this. Avi Loeb jumped right in and said, aliens. And that's just not my first guess at something if I don't know what it is. All right? I will scratch my head more before that's the conclusion I land on. Because if everything you don't understand, you want to credit aliens, I don't know what is that. And it turns out some geologists figured out it's probably outgassing of a kind we're not familiar with on solar system style comets. It is, after all, from another place. Okay, so it easily accounts for it. But Avi had his sort of day in the sun where everybody wanted to hear how it is that aliens are visiting our solar system. By the way, half of y'all are physics. This is MIT, right? So y'all are physics fluent. So the anomalous acceleration was a single extra force operating on it that altered its path from what would otherwise be a pure Newtonian trajectory. Okay. I'm thinking if it's aliens, they would zigzag through the solar system. They're not going to still be on a smooth path. If they have controlled acceleration, my gosh, nothing's stopping it. And if it did a planetary tour and hung out, checked out the Earth, then I say, Avi, let's revisit that suggestion that maybe aliens are in control. So that's what you have there. Oh, by the way, the monitoring of the sky for things that go bump in the night is the sole task of a very new telescope, which was previously known as the Large Synoptic Survey Telescope, LSST. It got renamed, thankfully, to the Vera Rubin Telescope, one of the more famous members of our community who discovered dark matter in galaxies. She died a few years ago, Vera Rubin. So it's called the Vera Rubin Telescope. This telescope, and it dovetails back to your whole existence here. This telescope, forgive me, I'm not fluent in the numbers. I'd have to look them up, and they're very look-upable. But it's basically going to take a snapshot of the entire sky multiple times a night, thereby making a movie of the night sky. Now you say to yourself, why do you need a movie if nothing changes? Well, how do you know nothing changes? You've never had a movie of it, okay? And there are other things where you can, if you only observed something at the same time each night, suppose something blinks on once every 24 hours. You'll think the thing is constantly in the same state because you don't have data from the rest of the phasing of what that thing is doing. This telescope is going to solve that. And it is the largest data project there ever was in my field, and it is almost entirely computing. There's the pipeline of data that gets analyzed, and there's a serendipity mode where it gets automatically analyzed and compares it with an image the night before or earlier in that night. And if anything is different, it goes back to it and signals other people to possibly turn other telescopes onto that zone. So this is modern astrophysics that would be impossible without very clever programming of the management and analysis of data.
Where should the Vera Rubin telescope look for life?
Yeah, if it's coming in on a flying saucer, it'll find it. But if you're going to look for life chemically or in other ways, you want to send a probe maybe to the planetary surface, as we've done with Mars, the Perseverance rover. It's called a rover, but it's really a mobile biolaboratory. And it's also got some geophysics tools in it as well. We don't have a word for Mars geology because geo means Earth. So Mars geology, it's kind of a misnomer. But anyhow, it's doing these experiments in an attempt to establish and understand and characterize the environment on Mars so that we can pose the next round of questions. Was there ever life there? Is there life there now? If it's there now, is it underground? And how far underground? And if there's water there, is the water liquid? Is there a heat source that we haven't reckoned before? All of these questions get asked in the search for life. But I can tell you that if a flying saucer comes through our airspace, the Vera Rubin telescope is going to catch it early.
Speaking of looking for life on Mars, do you expect to see life in the seas of Titan in our solar system?
So Titan. So just to catch people up, Titan is one of the moons of Saturn, and in fact, it's one of the biggest moons in the whole solar system, actually, and it has an atmosphere. Oh my God, a moon with an atmosphere. Well, if you have an atmosphere, that means you can establish sort of partial pressures on things that might then be sustained as liquid. All right. Once you lose your atmosphere, liquids are not stable, right? And they just evaporate out. So if Titan has an atmosphere, let's look for liquids. And what's the atmosphere made of? Well, it's mostly methane. All right. CH3. So you got methane, but Titan is way out there. All right. Jupiter is far enough. Now you double that and you get to Saturn, and the moon around Saturn, that's way outside, the Goldilocks zone. Okay. All right, so we're not going to expect liquid water. No, I don't think so. So you get there, and there are these boulders. Because we've landed on the surface, the European probe attached to an American orbiter around Saturn, Huygens probe, named after Christian Huygens, a Dutch polymath from the 1600s. So he, and 1700s. So the Huygens probe deployed and descended onto the surface of Titan through the atmosphere. And it was able to make a soft landing because there's an atmosphere, you could just use a parachute. When we landed on the moon, you couldn't use a parachute. You needed to spend fuel to prevent yourself from crashing. This is part of the fuel budget that you have to consider depending on where you want to go in the solar system. So here's Titan, but then you ask, well, what's the temperature of Titan? And I forgot what it is, but it's cold enough to liquefy methane. Oh my gosh. Well, if you can liquefy methane and there's partial pressures to keep it liquid, we should look for lakes. And oh my gosh, they found lakes, methane lakes on Titan. Okay, they were closer to the poles than we had thought. Maybe there'd be more towards the equator. So, all right, well, where's the water? Because water is not uncommon in the universe. Oh, the water's frozen into bedrock. So here on Earth, when we see rocks, we say rocks are solid. No, rocks are solid at room temperature. Go inside a volcano, rocks are liquid. Okay? So what is water on Titan? It is frozen solid. It is the bedrock. And those are the mountains. Those are water. And the liquid is liquid methane. So let's ask the question, what does it take to have life? Are we going to invoke a water bias and say, life as we know, it's got to have liquid water, so let's look for liquid water? Maybe all life really needs is liquid. And maybe methane, liquid methane, is a foundation for a whole other kind of life form that our imagination prevents us from conjuring because we are so earth biased in our biology. So I like the question, could there be life on Titan? Because if there is, it will completely stretch our understanding of all the ways of being alive.
What chemistry do you expect non-DNA life form to use?
So here's an interesting, let me sort of not answer that question with another comment. If you speak to geologists and they look at Mars, they see rocks and they say, oh, there are iron oxides and there's silicates, and they can use the same vocabulary that they use on Earth when they're talking about the rocks on Mars. So what it means is minerals, geology as a general field, is highly portable in your understanding of processes from one rocky planet to another. Well, if let's call that a universal thing that minerals do under certain temperatures and pressures, should we not presume that the way life formed on Earth wouldn't be exactly the way life would form anywhere else? Should we require that identity gets encoded in ways that do not invoke DNA? When geologists are not saying, oh, here's an element we've never, no, we've got the elements, we've got the periodic table. Planets are not inventing new elements that we haven't already discovered. We've got that, okay? So could it be that biological processes are as repeatable as the formation of rocks? That's an interesting question. And if that's the case, then we could declare that the DNA molecule is an inevitable consequence of complex chemistry and no longer have to ask ourselves, what would life be like without DNA? So that's a way to not answer your question, but with another sort of probing thought about this. And by the way, life on Earth formed really fast. We've been around 4.5 billion years. The first 500 million, it was the conditions on Earth's surface were very hot. We were still accreting material from the solar system, so that would break apart complex molecules. Just the binding energy is less than the impact energy of rocks. So then finally we cool down. Now we can make complex chemistry. Once they start the clock at that point, it took 100 million years for life to show up. Yeah, that sounds like a long time, but what's 100 million years compared with 4 billion? So, left to itself, Earth made life. And so, why should I think, and just because we have a hard time making life in the lab, we haven't figured it out yet. We got top people on it though. Just because we haven't figured it out doesn't mean nature didn't figure it out, or that nature won't figure it out wherever it has access to complex chemistry. And as your audience surely knows, all the ingredients of life, the hydrogen, the oxygen, the silicon, the carbon, all of that are the most common ingredients across the universe. So if we were made of like a isotope of bismuth, you could say, yeah, life is rare. Life as we know it, yeah, we're special. But no. The top 3 chemically active ingredients in the universe in order are the order in which you find them in life on Earth. Excuse me, so the top 4 is hydrogen is the number 1 element in life, okay? The number 2 element in the universe is helium, but it's chemically inert. It doesn't count. What's next? Carbon, oxygen. These next 2 elements are 2 and 3 in the universe. The oxygen is more abundant than carbon. And that's what we're made of. So life was really opportunistic with its ingredients. And plus, you got carbon in the middle of it, which is extraordinarily sticky, chemically sticky, and it can bind to itself with its 4 electrons, and it can bind with another 4, and it get 2, 2, and 2. You can get 1, 1, 1, 1, and 1, no, 1, 1, 1, and 1, and it can make long chains, just like what the double helix is. So, anyhow, I'm going to vote for the double helix, at least for now.
That's great. Okay, more about our universe. Is our universe expanding within a different universe?
I'm sorry, are we expanding?
Is our universe expanding within a different universe?
Oh, yes. So let me shape that up a bit here. So we have modern understanding of the application of quantum physics to the early universe, the Big Bang, basically. It allows us, if you only use sort of Einsteinian physics for the Big Bang, it's kind of limiting, all right? But when the whole because quantum physics is the physics of the small, and general relativity is the physics of the large. But at the Big Bang, the large was small. So if the large is small and rivals the sizes of particles, then you get to apply quantum rules that impact the entire universe. That's a fun place to hang out. It's kind of also a shotgun wedding there because the two don't really play well in the sandbox, all right? You need like a third understanding of how this works. And this is where string theorists come in and other sort of high-level cosmologists. But when you follow some natural consequences of this marriage, one of the things, and with an inflationary scenario, Alan Guth, an MIT professor, one of the pioneers of that concept, when you invoke this, you learn that this thing can make multiple universes, multiple expanding bubbles. And so if that's the case, then we are one expanding bubble inside of a larger universe that has other expanding bubbles within it. Now, you could be an expanding bubble in an expanding universe where everybody is expanding and you'll never actually bump into one another. If the universe is expanding faster than your bubble is, for example, okay? So then you'll never catch up. And that's an interesting scenario. And you can rank these multiverses by their simplicity or their complexity. And that one would be the simplest example of one. Because these other universes still share, in a way, they share our space-time. They would have the same laws of physics. They might have a different amount of matter in them or whatever, and there could be an infinite number of them. In this book that just came out a month ago, can I show it? Is that crass? Cosmic Queries. I've got to show it there. Cosmic Queries. This is a book that's collected the deepest questions we've ever asked about the universe in the history of our civilization. So in here is like, how did it all begin? How did it get to be this way? What is it all made of? How will it all end? And there's a whole section here on what does nothing have to do with everything? Because how do you define nothing? Is it where there's no matter? Well, suppose there's energy. Okay, let's take away the energy. Is there no quantum phenomena? Let's take that away. Well, there's still the fabric of space and time getting curved by gravity. Okay, let's take that away. Well, then there's still the laws of physics that apply. Well, let's take that away. So what does it mean then to have a region of space where you don't even have laws of physics that apply? We go there in this book because there's a category of questions that are just dangling by our ankles off the cliff, right? And we're dangling there because we don't, is the question even the right question that we're asking? So that's one category of universe. A whole other category of universe allows the different multiverses to have different laws of physics within them. And they get more and more spooky and scary, actually, for me, because I lose sleep over some of these. And so it's a fun exercise in pushing the limits of your physics and your math to see what fate awaits us. And for me, the scariest fate is the possibility that the accelerated expansion of the universe, this is that dark energy you may have read about, if that goes unchecked, then that stretching of the fabric of space and time will overcome the elasticity of space-time itself. And when that happens, it will rip at the pixelated level of what the universe, of what constructs the universe. And that's the Planck length. This Planck length, all right, that is the quantization of the universe that general relativity doesn't see. That's why you needed a third theory to put them together. But that pixelization of the universe, as you expand, there's a point where it wants to expand that. How do you expand the basic building pixel of the universe? You can't. So it's called the Big Rip. And if it goes unchecked, that'll happen in about 20 billion years. So that's what I really lose sleep on. We want to talk about other universes. Time to move to another universe then.
Well, speaking of our own universe, how will our galaxy still collide with Andromeda despite this expansion?
Good. It'll collide before that becomes a problem. Okay. Yeah. So as we continue to expand, the strength of the dark energy gains relative to the strength of gravity. And right now we can still have solar systems and galaxies and nearby galaxies falling towards one another. You go a little too far away, the expansion of the universe is overriding the urge of the galaxies to come together, and that's where we get our whole understanding of the expanding universe. But nearby galaxies, our strength of gravity is strong enough so that the expanding universe is not overtaking this just yet. And we will collide with Andromeda in 6-7 billion years from now. And we even have a word for that new galaxy. I thought it was very creative. It's called the Milkomeda or Milkomedia. But there's Andromeda and the Milky Way. Milkomeda, I think it's a little clumsy, but it's cute.
How close are we to finding a unified equation that explains all matter?
So I have a lot of thoughts about that. Not that I have any actual talent to participate in that exercise, okay? But I think a lot about it. And I just wonder, that very question contains a very deep bias that the universe actually can be described by a simple equation. That's an interesting philosophical bias. You're imparting your own sense of order and elegance onto a very complex universe. And I try to stay open-minded. Maybe the universe is just messy, all right? Maybe all the forces don't come together as one. Maybe. I'm going to allow for that. You know why? Because I studied Johannes Kepler, a mathematician, German mathematician around this time of Galileo, and Shakespeare and Queen Elizabeth, very fertile time in Europe. Around the year 1600. He was sure, because he was a mathematician, and he knew about the Platonic solids. You know about this if you know anything about any geometry. There's only 5 Platonic solids. So these are solid shapes where every surface is an identical polygon. Okay, an identical uniform polygon. So a triangle. So what do you have? You can have 4 triangles will make a pyramid. That's one of the 5 Platonic solids. Another one is a cube. Each side is a square. And you keep doing this, there are 5 of them, it turns out, and no more and no fewer. All right. So he loved math, and he knew the universe must be perfect. God made it. God's perfect. Math is perfect. So clearly, the movement of the planets around the sun must have, and there are 6 known planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. And he has 5 of these solids. So he decided to nest the solids, all right, and then put orbits in the gaps between them, because if you have 5 solids, you have 6 gaps, or there's an outer zone as well. And if you do that, he's saying, yeah, that's got to be it, because that is beautiful, because it is simple, because that's how it must be. And he spent 10 years working on this. And he said, no, it's not that. And they're not perfect circles. No, they're ellipses, and they're different shape ellipses at that. And so the whole perfect philosophy of what was guiding his inquiry had to be thrown out the window. So maybe there's a unified field theory that captures all the forces of nature, simplifying everything in the universe into one equation. Maybe. But my read of history tells me every time we layer our own requirements on what nature ought to be, we end up with egg in our face. So I'm not betting on it.
Should we put more effort into colonizing Mars?
I would ask, why would you want to colonize Mars? What's your goal? I'm asking you right now.
The idea of colonizing Mars could help us from escaping our climate Armageddon, for instance.
Okay, good. All right, so that's a common thought, and it makes a good headline too. And Elon Musk and Carl Sagan and Stephen Hawking, some very visible thinkers in recent decades have made very strong suggestions that we should become at least a two-planet species to ensure our survival in case there's some kind of catastrophe or Armageddon rendering us extinct on one of the planets. That makes a good headline, but I'm a little more practical than that. So I'm swimming upstream in the ideas I'm about to share with you. They're not ideas. My sensibility is different from that of others, and here's why. All right, if you want to colonize Mars now, well, you can't, because you can't breathe the air. So you have to build some kind of habitat module, all right? So if you build a habitat module and then you go to Mars, well, you're not really living on Mars. You're living on Earth on Mars because you just created a habitat. Well, that's like going to Disneyland, all right? I don't mind visiting Mars and going to Disneyland, spending a few weeks, all right? And then coming back, sure. But you want to colonize Mars and have people live there permanently? On a planet where you can't breathe the air? People say, well, we had explorers from the 15th century who went out not knowing where they'll land. Sure, Columbus visits the New World, all right? He gets off his ship. He can breathe the air. Other human beings are there to greet him. He can eat the fruit growing on the trees. And the trees are made of wood, just like the trees in Europe. If his ship breaks, he can mend his ship. If you crash land on Mars, you can't go to the Home Depot and get pliers, or you can't get anything, let alone not being able to breathe the air. So, in order to really become a two-planet species, we have to terraform Mars. Terraform it. I love me some terraforming. Don't get me, I love it. Okay, great idea. So you seed it with microbes and certain chemistries that then operate on their own chemical forces to generate oxygen and all this. Okay, so now we figure out how to terraform Mars. It's a stretch, but it's not out of reach. It's not out of our imagination. Terraform Mars. Now we ship 1 billion people there. Now we have our eggs in 2 baskets instead of 1. All right. And now here's my issue. All right, you're worried about a killer asteroid? It seems to me that whatever effort it took to terraform Mars and ship 1 billion people there is greater than whatever effort it would take to deflect the asteroid. I'm just thinking. An asteroid's coming, let's deflect it. No, first, let's terraform Mars and ship 1 billion people there. And then everyone here dies so that they've survived. No, let's deflect the asteroid. All right? What else? There's a killer virus that goes around. And, all right, what investments will be required in virology to create a perfect antiviral serum? Is that in reach? I don't know. I'm guessing it's less money, less time, and less energy to terraform Mars and ship 1 billion people there. And finally, here we are, we're trashing this planet. Climate change makes it unlivable. Oh my gosh, what do? Okay, so we terraform Mars and ship 1 billion people there. But wait a minute. If we have the power of geoengineering to turn Mars into Earth, then we have the power of geoengineering to turn Earth back into Earth. So all of these arguments, I don't see them having practical meaning as a solution. I want to be a two-planet species, but the motivation shouldn't be so that half of us can go there so that one of these planets could go extinct. No, save everybody. Let's save everybody. Is that so wrong? Let's just be a two-planet species because that's fun to do. Because that'd be great. All right, that would be my reason for doing it, not as the imagined excuse to save the species.
Well, speaking of climate Armageddon, what do you think we need to do to save the planet?
Yeah, so it's Armageddon. When I think of Armageddon, I think of something more catastrophic than what climate change will bring to us. Okay, so we are putting carbon that has been uh, long buried in the ground, with turning that into carbon dioxide, all right, as the product of burning fossil fuels, and all right, so we are warming the Earth. This will have catastrophic consequences to coastlines as we melt the land-based glaciers. All right, and all that water sort of flows into the oceans, and the ocean levels rise. I live in New York City. You can do the calculation. If Greenland loses its ice and Antarctica loses its ice, the water level will rise to the left elbow of the Statue of Liberty. So basically, all of New York City is underwater, and so is basically every other major city we've ever built in the history of civilization, because cities were built where there was commerce, where there was transportation, and where's that? That's on the water's edge. So if all of what founded civilization is put in threat because of these rising tide waters, then yeah, that's a really bad future for us. But we will survive it as a species. There's not. It's not an Armageddon. It's a slow burn. Actually, it's a fast burn, and we're not going to be able to respond nimbly enough to it. You have to pick up every coastal city and move it inland 100 miles, all right, or 50 miles. Can we do that over decades? No, because these cities took centuries to build and to perfect and to develop and to have them function in the ways that civilization needs and requires. So now the reason why I say this, there was a day before we had fossil fuels. Earth, all right? It's called the Carboniferous era of Earth. All that carbon was plant life, okay? And Earth was hot. We didn't have polar ice caps. Life was doing just fine. But humans had not yet come along, and humans had not yet built cities dependent on what we presumed would be a stable climate. So Earth will definitely survive anything we do to it. But our civilization, as we've come to define it, will not. We can call that Armageddon, but there'll be still people who will survive, but it'll be a really ugly world at that point.
Neil, we are coming up to the top of the hour, so let me ask you one last question.
Well, ask two questions. I'll answer each in half the time. How about that?
Ask two questions. Okay. What do you see as a landing on the moon moment for today's time? Something that transcends national interests, something that can unify the world.
You know what could unify the world? A virus that can attack any and all humans and would be a pandemic, and we all have to band together to fight it. Oh, that already happened, and we didn't band together. Oh, silly me. Generally, people band together when they have a common need and a common urge. And the COVID virus was a practice run for invading aliens. An invading alien wants to kill all humans. It's time to get together, folks. Pool our resources. Put aside your tribal ways. In fact, let's collect your tribalism into one sense of the world. And that one sense of the world is that, what race are you? We are all the human race. All right, now let's fight this common enemy. We failed that. The only success story was the medical researchers who developed the virus and the antiviral vaccine in record time. That's why I wouldn't give it quite an F of a COVID year. I'd give it like a C plus. And all that, the fact that it's not an F is because we got the vaccine going, even though the distribution had problems. So, why should we need a Sputnik moment or a moon moment? Why? We know we all enjoyed it. We know it transformed our culture, our civilization, our technologies. It stoked our economies. We know this. Why do we have to feel threatened again just to engage in exploration on the frontier, knowing from past experience that such exploration can be transformative to how we live? So, yeah, that's my answer to that question.
Thank you for that. Okay, last question.
Yeah.
You could go back to your 21-year-old self, which is the age of many of the students who are with us today. What advice would you give?
All right, I have it. I have what might be an unsatisfying answer for you. Okay. Everything I am today, everything, down to the tiniest detail, is what it is because of throughout your life. You test things, you experiment things, and you learn. You learn to do things better, or this didn't work, and you learn this. If someone goes back in time and says, don't do that, that's not going to work, and they just tell you, then that's not part of your life experience. That's just somebody handing you their life experience. So when I think of advice, the advice is keep exploring. Just keep doing what you're doing. And yeah, there'll be some failures in there. You'll learn from those. There'll be some successes. You'll do more of that. But you will have experienced that on your own as the consequence of your own creativity. And so it reminds me of, it's now, I don't know if it's an apocryphal story, but let me just tell such a story. So you have an immigrant who comes to the United States with $20 in their pocket, right? And then they work hard and they struggle and they take odd jobs and then they finally own a business, all right? Because they worked hard and they worked their way up and they had more, they saved, they own a business, they get married, they have children, and then they have multiple businesses and they become really successful and they lives in a whole mansion. But that person struggled his entire life trying to make ends meet, barely getting food on the plate. Okay, so now they're well off and they have kids. And they make sure that the kids do not struggle the way they did. They make sure the kids always have food on their plate the way they did. Because I don't want my kids to struggle the way I did. And then the kids grow up and they're 21 years old and they're deadbeats. And then the parents say, where did we go wrong? We gave you everything we didn't have. That's where you went wrong. Because you became what you were because of the challenges and struggles that you faced in your life. I think we undervalue struggle in what role it can play in your future success, in your future perspectives, your outlooks, your sense of the world. Especially since almost hardly anything worth achieving will you end up achieving without a struggle. And if someone says, here, just do that, then you don't have to struggle. Well, okay, you made your life easier, but is that really what, you just want an easy life? Really? Okay, go ahead and get it. You can take your easy life. What's going to happen when there's some stress in your life? Oh, you'll freak out, all right? You won't know how to handle it. So I don't know. I don't want to play psychologist here, but there are people who are having trouble in school because they're not socialized in the right way and they're getting bullied. So they take them out of the school. They put them in a different school where everyone is nice to each other. And then when they get older and they get into the workplace, and then there's the difficult person in the other cubicle, they don't know how to handle them. Okay? I keep thinking so much of what also goes on in school beyond the classwork is the learning how to deal with difficult people. And so, yeah, so in terms of advice, no, I don't know that I have advice. If suppose I said, yeah, spend less time doing athletics and more time, because I did a lot of athletics, and more time in your studies, yeah, maybe I could have done that. But then I wouldn't have this appreciation for sports that I currently do. And I wouldn't have the conversations that I have with sports enthusiasts. And I'm actually like friends with, strong acquaintances with the coach of of the Seattle Seahawks. That's just fun, okay? And I have a fluency in sports that has enriched my life in ways that wouldn't have been there if I gave up all my sports at the time and then I only had my head in the books. I used to I didn't doodle in classes. I don't have any art ability, but I would play with my pen as though I were a calligrapher. And I would do fancy lettering. And it turns out that the New York Times, the bannerhead, it's in Gothic. A lot of the letters in the New York Times appear in my name. So I'd pull out those letters and I'd do them. And there I am, like, and I really should have been paying attention in class. And how does this accrue at all? Well, I now have a collection of fountain pens, and I dip them in ink bottles. And when I sign my books, okay, I sign them with calligraphy pen, and people they like that. All right, I do that, and it gets on their doorstep, and it shows up on social media. A little thing like that. That's enriched my life. It's enriched the lives of others. So don't tell me, future person, what I should or shouldn't be doing. I'm perfectly happy to experiment and learn from it on my own.
Thank you for that, Neil. Thank you for being with us. Thank you for inspiring us and encouraging us. I look forward to the next time you and I have a chance to meet. In the meantime, we'll work really hard on those self-driving cars.
Yes. In fact, I want to get you on my podcast, Star Talk, the day the first self-driving car, fully self-driving, drives off the lot. I want you in my studio to interview you. Oh, one thing about here's the advice to give my 21-year-old self. You ready?
Go for it.
Make sure you actually do learn from your mistakes. That's the advice. All right? You don't want to ever make the same mistake twice. Then you're just wasting your life and time and everybody else's.
Awesome advice. Thank you, Neil.
Hi, Daniela. Always good to see you. And I love you've got the Horsehead Nebula behind you. A little bit of our universe there. There's the horse's head. You're blocking the thing that gives it its name. I just want you to know that.
Well, that was a test for you.
Okay. No, I know my sky. Who you think you're talking to here?
This was taken in my backyard.
Oh, it was. Excellent. Excellent. Mm-hmm.
So, okay.
So was this. This was taken in my backyard.
Well, thank you all for joining us. Thank you, Neil.
Okay, and everybody in MIT land, stay strong, stay smart, and you all know that you're going to become the engines of tomorrow's economies and tomorrow's science literacy. Just keep it going.
Absolutely.
All right. Take care.
Bye-bye.
Bye.